My presentation today has to do with our graduate programs in civil and environmental engineering. But, would you please go ahead and change the next slide, please? So I want to cover a couple of main topics today. One is the makeup of our programs themselves. So the first part of the presentation will cover the programs that we offer, how are they structured, what are they intended for, and how do you go about getting your degree. In the second part of the presentation, I'm going to give you a little bit of a feel for the type of research that we do at UTSA, the facilities that we have. If you were to come here, some of the really exciting cutting edge work that our students are doing here at UTSA. Next slide, please. So within the purview of the civil engineering field, we offer programs at the master's level and at the PhD level. At the master's level, we have two programs, and that is sometimes a question that we get a lot. It gets a little bit confusing. We have the MS and the MCE program. I'm going to talk a little bit about both and what the differences are between the two. And then at the PhD level, we have two programs. One is managed, we're now a division of civil engineering, so it's within the division of civil engineering. And then we have a joint program with the College of Science, which is the Environmental Science and Engineering PhD. Next slide, please. So at the master's level, as I mentioned, we had two programs. One is the Master of Science and the other one is the Master of Civil Engineering. The Master of Science program involves doing research and producing a master's thesis, while the Master of Civil Engineering program is more of a practical program that is for students. The latter, the MCE program, is often a good vehicle for folks that are doing part-time work and want to enhance their career opportunities, and we have a lot of students that work full-time and then enroll in our MCE program as part-time students. In the Master of Science, because of the thesis component, sometimes is more a better fit for students that are participating full-time, who may want that research experience at the master's level, or who may be thinking about moving on and moving forward towards a PhD. The experience doing research is going to be helpful to them. Next slide, please. So the master's, both programs cover 5 technical areas: environmental engineering, geotech, structures, transportation, and water resources. And now we're integrating also with the construction science. We're in the same group with the new structuring of the Clese College of Engineering and Integrated Design. And so we also have some construction courses that have become available. And we continue to grow our opportunities in the construction area. Next slide, please. For the Master of Science requirements, as I was saying before, this is a thesis master. So you're going to have 24 hours of elective courses. Typically, a graduate level course is 3 hours. So we're talking about 8 courses plus 6 hours of master's research. That's where you do your master's thesis, for a total of 30 hours beyond the bachelor's. And we give people a lot of freedom in the types of courses that they want to take. We want them to work with their advisors in developing a program that suits their career objectives. And so we typically encourage people to take 5,000 level courses or above in civil engineering, in other fields of engineering. We got students that have interest in areas like machine learning, for example, or other areas that are an expansion of the civil engineering field. And so we're quite happy to let them take courses like that because they feel that it makes them more marketable. And then, within reason, we can also, we'll also consider allowing people taking other courses. For environmental engineering folks, there's a great synergy with environmental science or with programs like geology or geography, which may be helpful. Next slide, please. The Master of Civil Engineering course is tailored for folks that don't want that thesis experience. So this is in lieu of the thesis, you go from 8 courses to essentially 11 courses in 1 hour of seminar. You take 3 more courses to make up for the difference between the thesis and the non-thesis option for a total of 34 hours. And again, we give people freedom. Folks that are doing this program in working full-time oftentimes want to focus on courses that are practical, that are applied, that are relevant to their design careers, and we offer a lot of those. We have since the pandemic, we have begun to offer some of our courses online, and we will continue. It is our plan to continue to do that. To give people flexibility, because we find that for some of the folks that are working full-time, that gives much better opportunities. It gives more options to keep making progress to graduation without necessarily having to travel to campus several nights a week. Just before we move on from the master's level, sometimes I get questions where people ask, if I take the MCE path, is that going to preclude me from pursuing a PhD later? And the answer to that, of course, is no. There's a benefit to doing a master's thesis. It prepares you and it gives you experience in doing research. And so it's certainly helpful when you're preparing to do a dissertation. But we don't pay attention to which type of degree you have when we consider you for admission into the PhD program. Next slide, please. Okay, so this slide presents the milestone, how the program goes. If you were to come in the first semester, if you're in the Master of Science program, we want you to make sure that first semester you get your feet on the ground, you identify the technical track that you want to specialize on, you develop a plan of study, and you latch on to an advisor. And the same goes for the MCE program. I think the advisor is less of an urgent thing, and we have myself, I can serve as your advisor, or I will pair you or try to pair people with experts in their specific area of specialization. But it is important that you begin to identify a technical track that you want to specialize on and look at your plan of study. And within civil engineering, master's degrees and PhD degrees are for narrowing your field. Within the bachelor's, we try to give people a broad education and get them to learn a little bit of all the areas. Within the master's, what is going to make you money and is going to prepare you to advance in your career is to become an expert. And it's difficult to become an expert in all areas. So this is where it's more beneficial for you to pick a single area or maybe a combination of areas. A lot of market, for example, for folks that have expertise in geotech and structures or transportation, in water resources, environmental engineering and water resources. We understand that there are paths to be had in that boundary or in those boundaries, but we have to be thinking in terms of specializing. End of second semester, if you have an MS, then you need to be putting together your thesis committee and clearly defining expectations for your master's thesis. And then at the end of the second year, you should be done with either program. If you're attending full-time, if you're attending part-time, it's certainly going to depend on how many classes you take every semester. Next slide, please. as I mentioned before, we have two PhD programs. We have the PhD program in civil engineering, and we have the joint program with the College of Science and Environmental Science and Engineering. Next slide, please. Why do you want to pursue a PhD? This is something that you're considering. Nowadays, and certainly in the field of civil engineering, is not a question of whether you want to go into academia or you want to go into professional practice. I think there's certainly room for PhDs in both. In academia, it'll be required. In professional practice, I think that they are highly specialized firms that do work like forensic engineering, do work like general consulting. I have former PhD students who work on both. Research labs, one of my former PhD students works in one of those, where the additional knowledge of having a PhD is an essential qualification. But realistically, if the master's was, we talked about specializing the master's, and the PhD, that's even more so. Not only are you going to become specialized in a single area, but you're likely going to become the world foremost expert in the particular problem that you investigate in your dissertation. And that may include you having deeper and greater knowledge than your advisor, because you'd be the one that'd be crunching the numbers and doing the legwork in studying that problem. Next slide, please. So our civil engineering PhD has 6 tracks. 4 are more traditional civil engineering tracks in orange, shown there: structures, geotechnical, water resources, and transportation. And that is more of the traditional engineering side of the ledger. We have 2 additional tracks, formerly of the College of Architecture, is no longer a college. The 2 have merged together. But there's still divisions within the college. And those are building performance and construction science and management. So when you apply for a PhD program in civil engineering, you're going to have to choose a track, and in your statement of purpose, then preferably give your expertise and your plans for the particular track that you're seeking to pursue. Next slide, please. So the civil engineering PhD program is the first one that I'm going to go over. We have the requirements there on the left: 60 credit hours beyond the master's, 15 credit hours of doctoral research, and 15 credit hours of dissertation research. You're going to have to take 3 exams. There's going to be an oral or written qualifier exam, which will take approximately 1 year by the end of your second semester here. Then when you completed your 15 credit hours of doctoral research, those hours are used to develop a plan for your dissertation that you're going to present to your committee. And it's a process where you take this oral comprehensive exam is a process in which you sort of forge a contract with your committee about what is it that you're going to do, what is the scope of your dissertation, the amount of work that you're going to do, is this a worthwhile problem? All of these things are addressed in the oral comprehensive. And the thought is that after you pass your oral comprehensive, you're on the right track to graduation. You just need to complete whatever you agreed with your dissertation committee was going to be the scope of your dissertation. And that's what those final 15 credit hours of dissertation research. And then, of course, at the very, very end, you're going to have a final exam to defend your dissertation. There's an asterisk there. If we take a lot of applications from master's students seeking PhD, we will also consider extraordinary students with a bachelor's degree. You don't have to have a master's to apply to the PhD program. But if you apply to the PhD program with a BS degree, you will be required to have 15 additional credit hours of courses. Next slide, please. So this is essentially what I was referring to as a timeline. First semester, we want you to come in, identify your advisor, and start thinking about your dissertation topic and forging a plan of study. End of year one, you need to take your qualifier exam. End of year two, you need to have forged a dissertation plan to the point where you can take your comprehensive exam to defend your dissertation proposal. And then that gives you an additional year focusing on your dissertation. And you should be in a position to defend at the end of year three. Sometimes dissertations can take a little bit longer, but we'd like, and we will keep tabs on people to make sure that you're making progress to graduation. We really want to keep on track those first three milestones be achieved within the timeline that is shown there. Next slide, please. So we talked about 60 credit hours beyond the master's, and this shows a breakdown of those 60 credit hours. It's not 60 credit hours of courses. They're 28 hours of elective courses, 2 hours of graduate seminars, so 30 hours. Half of the requirement is on courses. We are talking about comparable to the master's 8 or 9 courses that you need to complete the course requirements for the PhD. And then you complement that with 15 hours of doctoral research before you've defended your dissertation proposal, and 15 hours of doctoral dissertation research. Next slide, please. So I'm not going to dwell on this. This information, I wanted to put it out there. This is being recorded and people can look at it in more detail later. But these are some of the courses that we offer in the different areas. So I hope this would be helpful to you if you're considering UTSA and thinking about what are some of the courses that you can take here. These are specific to structures. Next slide, please. These are courses, elective courses, graduate courses that are specific to geotechnical engineering. And these are specific to transportation. And the last one is on water resources. Those are the courses that we offered then. Next slide, please. Okay, so I owe you courses in the 2 tracks that are not the purview of the Civil Engineering Division. So we'll if you want information on construction science or building performance tracks, feel free to reach out and we will put you in contact with people that can provide that information. For the environmental science and engineering PhD, historically, it was our first PhD program. It had, so it has 3 different tracks, one in environmental science, one in environmental engineering, and the other one in civil engineering. I think in the near future, we're probably going to do away with the civil engineering track because it's redundant with the civil engineering PhD. So there's no reason for it to exist anymore. Next slide. The requirements are very similar to those of the civil engineering PhD. 60 credit hours beyond the master's. You also have to take your qualifier, 15 hours of doctoral research, and 15 hours of dissertation research, and then final exam. Next slide, please. And so the course requirements in this program are a little bit different. In that there are 10 hours of core courses that are required and 18 hours of elective courses. The PhD program in civil engineering makes no distinction. There are no core course requirements, and we make it something that you define with your advisor what what courses you need to take in this. As a result of this being a joint program with the College of Science, I think the faculty decided they would have 10 hours of core courses that are applicable to everybody in the program. That's the main difference. The dissertation and doctoral research hour requirements are the same as the civil engineering PhD. Next slide, please. So just to give you an idea, what are the core courses in the ESE, in the Environmental Science and Engineering PhD? So that's a listing. In among those, you're going to have to complete a total of 10 hours. Next slide, please. The milestones of the PhD program are very similar to that in the civil engineering PhD, and will follow the same process to make sure that you're making progress to graduation. So end of year 1, you need to have taken your qualifier. End of year 2, you need to complete and defend your dissertation proposal, and our goal is to have end of year 3 having you do your dissertation defense. Next slide, please. Okay, so that describes our programs. I'm going to take the latter part of my presentation here, and I'm going to talk a little bit about the types of opportunities and research that we have at UTSA, highlighting some of the work that our students are doing, which is truly fantastic. So we have a research portfolio in all those areas. I'm not going to go over research that is done in every area. I'm going to focus in two in this presentation, the transportation folks and the structures folks. We have a fairly new Geomaterials Lab. Is one of our nice facilities in the civil engineering complex. And they do have state-of-the-art equipment to do research on asphalt and how to make more durable, resistant, how to do quality control and also asphalt mixes. So that's the material side of the program. Of course, we have folks that work on intelligent transportation, interested in electric vehicles. And there's a lot of crossover also between the transportation folks who work in traffic safety. They may intertwine, or they like to work together with our environmental folks, for example, to study safety under different weather conditions and risk factors presented by the environment. Next slide, please. UTSA in the last, I would say 6 years, has made a tremendous effort to improve its research facilities, and one of those that is one of our most beloved additions to research portfolio at UTSA is the large-scale testing laboratory. As you can see it there, it's a fairly large facility. We were fortunate to get a $10 million budget, so it's a significant investment of the part of UTSA, and it opened up many doors for us to do new research. Next slide, please. This image on the left shows the interior of the lab. On the right, if folks are kind enough to play the video, this is a testing program. We have a student that is doing his dissertation on blast resistant construction. He was interested in the properties of steel bars at very high rates of loading. And UTSA, not only our equipment has the capabilities to do it, but to test bars and to test at very high forces. But we also made a substantial investment so that we can test at very fast loading rates. So we have one of the better facilities in the state, in the country in that respect, both in terms of the capacity that we can test at, in the speed at which we can load, which allow us to do experiments that are relevant to earthquake engineering or blast resistant design. Next slide, please. You can see how fast the test of that bar progresses. So, okay, if we play the video, please. This is a test of a double T girder that we did in our lab. This is a fairly large girder, maybe 3 feet deep. And this is actually a very small test, but these types of elements are used commonly in parking garages. And we, in this particular case, we were trying to learn the failure of the girder as the test progressed. This is how they would fail in real life. Kind of scary if you think that you typically, you know, wherever you go, you park your car is going to be on top of that. You never wanted to get to be that, to look like that. And so our graduate students here at UTSA go ahead and break elements like those, so we can learn what is their capacity and how it is that we can build them to be safer. Next slide, please. We do a lot of work. So the videos that I showed before are highlighting experiments, physical experiments, breaking things, which is a lot of fun. We also do our fair share of computational mechanics work here at UTSA. This is done in structures, but other areas do it too. This particular study is one that a student did here at UTSA on the collapse risk of buildings subjected to earthquake. So you see the earthquake exciting the building in the bottom, and you see how it pushed it to the point where the building collapsed. And you see the little dots are indicative of damage that is occurring at each element. And of course, the red ones is where things went real bad. And so we do a lot of simulations like these. The student who did this study did thousands of simulations like these, trying to understand what are the factors that make buildings have a greater risk of collapse during earthquakes, with the goal of fixing them or identifying them so that be eliminated and people be safe. Next slide, please. Another one of the areas that we work in, this is particular collaboration between structures people and the water resources people, is coastal engineering. So we have Professor Testic is interested in rain and other areas of coastal engineering. And our student instructors do, these are multi-physics simulations where we study the effect of wave impact on bridge structures in this particular case. These are fairly sophisticated state-of-the-art simulations, really neat work here done by Arslan Matlesi, one of our PhD students at UTSA. And he is studying the wave impact problem on bridge structures, trying to understand how the properties of the wave, the waves and the bridges, again, affect the probability that a bridge be damaged or unseated, like this bridge in the simulation was. And this was a problem. You can go back. I have a lot of images like those, not in this presentation, but after the Hurricane Katrina, this was a very common happening throughout the Gulf Coast. There were many bridges in which the superstructure wasn't seated, like it happened in this simulation. So we're trying to learn what causes that and how can we design our bridges better so that that doesn't happen. Next slide, please. Okay, so here we have is another problem. This was done by Reza Nazuri here at UTSA. If you drive down the highway and you observe, there are all kinds of sign structures or illumination poles. You see illumination poles also in parking lots. They're very common. And you see the top left image shows a process because they're out in the elements. People put zinc coating on them to protect them for corrosion. And so they embed the poles in a zinc bath. That is, the zinc needs to be liquid, so it needs to be at a very high temperature. And they extract them. They come out with the coating, with the zinc coating in them, which protects them from corrosion. The problem is, if you look at the picture in the bottom left, or the picture in the top right, is that when that happens, there are very aggressive changes in temperature in the pole as it's being immersed that cause the pole to deform significantly. You see the image in the top right has the base of the pole and the connection between the pole and the base plate. And it deforms quite a bit. Deformations are a little bit exaggerated on the top right image, but it conveys the idea. And so it causes the crack the type of cracks that you see in the bottom left. So that's a major problem and a major concern, because you don't want to be driving in the highway at 70 miles an hour and the wind gusts topple one of these things in front of you. The outcome would not be good. So we did a very complex study here at UTSA. That's the video that you see in the lower right, where we simulate the process by which these poles are embedded in the zinc bath. The image, the video on the bottom right shows you the change in temperature of the pole and how it changes. But you know, of course, we can do much more sophisticated things like evaluate what are the stresses of the connection between the pole and the base plate, and identify measures that we can take to prevent the type of cracks that you see in the bottom left from happening. Okay, so that pretty much gives you an idea of some of the different problems that we deal here at UTSA on the research side. I could keep going for all day just in the area of structures, and I'm sure our folks that are experts in environmental engineering, folks that are experts in coastal engineering, they all would have very compelling stories to tell too about the work that students at UTSA are doing. Next slide, please. So I wanted to show you, we are a very diverse university. We have very diverse faculty. We have people of all different origins, national origins, you know, cultural and ethnic backgrounds. So it doesn't matter where you come from, you will find a welcoming committee in our faculty, and they may relate and they love to hear from students from all kinds of backgrounds and all kinds of origins. So I wanted to emphasize that. I think that's one of our strengths if you were to come here. Next slide, please. And these we're going to display quickly. You can find these in our web pages too. Those are some of our internet addresses for information on our master's program, PhD program, how to get a hold of the international office, and other resources that are important for students seeking to apply. Next slide, please. And then, of course, our application deadlines are displayed there. We typically have 2 rounds of admissions, one for the fall semester, one for the spring semester. We typically don't do admissions for the summer It's something that we could consider changing, but it's not, certainly not in the stars right now. One last slide, which has my contact information. I'm the graduate advisor, so I get to answer a lot of questions. Now, I am most helpful in questions that pertain technical aspects of the civil engineering program. If you want to know things like, you know, is it should I specialize in water resources, or should I specialize in environmental? Things like that are things that I can help you the most with. If you're interested in if you have a question about a transcript or your TOEFL score or something like that, that's typically not something that we do in the civil engineering program. That's managed by the graduate school. So I would encourage you to check with them. The way the process works is an application. You submit all your documents, and when the graduate school deems that you met all requirements, then those folders come to us. And so it's not. It's a team process. They have their part, we have our part, we try not to step on each other's toes. So the questions go in the same way. The things that have to do with admissions, what should I write in my statement of purpose, things like that are helpful on my side of the ledger. We have an administrative manager. His name is Desmond Graham. In the civil engineering department. He's also very helpful. He can help with questions, and of course our department chair, Torshul. So that, I believe, is in fact my last slide. So we'll leave the rest for questions.
I noticed you were recognized as the Peter T. Flon Distinguished Professor. What does that mean?
That's a great question. Thank you. Peter T. Flon was one of the folks that was instrumental to the creation during the first year of UTSA. He did a lot for the advancement of the university. So the university has some funds set aside for faculty. So it's an endowment. It means that we get a little bit of money every year. And for those of us who are a little bit older and have been around a little bit longer, we're allowed to spend some of that money. I'll be upfront. Most of my endowed funds are spent supporting students. So I will do that to provide scholarships. I think this past year, for example, I might have contributed to support 5 or 6 different students. That's my main concern. And we support them in different ways. We can help with some stipends. We can provide support for them to participate in a conference for their professional development. So that's what those titles mean is they're typically bestowed on people that have been around a little bit longer, have a longer track record, and the university trusts them to have the discretion of use those funds to support and help students in the best way that they can.
How competitive is it to get admitted into the PhD program with a bachelor's degree in civil engineering?
It is going to get different level of scrutiny. And I want to be clear here. We get a lot of truly outstanding applications for the PhD program. The applications that I see coming in, the quality of the applications is seldom my concern. I think that all of those students would be successful at UTSA, or most of them would be, if allowed to be part of our program. When it comes to the PhD program, we try to pair students with faculty. So we need, as a very minimum, a requirement that a faculty member be willing to take on the student as an advisee. So that's question number one, because we never want to be in a situation, that's a rule that I'm very, very, very stringent with, never want to be in a situation where we're bringing in a student and then all the faculty are looking at each other and say, I really don't, I have too many students, I can't advise the students, so on. It's never that people don't want to advise you. Sometimes they're overcommitted and they just don't have the bandwidth to do it. So number one, we're going to, as a minimum, pair you with a faculty member. Number two, which is preferable, is we want to be able to tie students with some form of research funding. That's key for the PhD program. I think is less important for the master's program, but at the PhD level, it is, because of the level of commitment that we're talking about and the level of effort that it takes to do a dissertation. And so the greater challenge is not for you to be considered for admission. I think where the competitive part is going to be is in you being able to attract the attention of a faculty member that is willing to advise you and is willing to support you. That's as a graduate advisor, that's where most of my energy is spent, and most of my concerns are this is what drove my biggest concern, is trying to pair students with faculty that can support them. And sometimes we can't do that, right? Sometimes we look at an application and seemingly we have an outstanding student. Research funding comes and goes. Sometimes we have an abundance of research funding, although I shouldn't say an abundance. I say sometimes we have more research funding and that there are lots of opportunities. And sometimes there are lulls in our research funding. And so even though we have extraordinary people, it makes it harder for us to admit them. I will say this: if your credentials are extraordinary, then again, you become my problem trying to find a way to bring you into our program.
There are many schools offering the Master's in Civil Engineering. What makes UTSA's program unique?
I would say without hesitation that we have outstanding faculty. And, I can speak to all the different areas. I know these folks. They're really good at what they do. So, for example, I'm going to bring up Professor Ganum. If you want to work on earthquake engineering, you'd be hard-pressed to find somebody better to work with in the world. So I think that's one of the reasons that sets us apart. We're going to have faculty in certain areas that are recognized as worldwide experts in what they do. I think there's another part of this also that has to do with UTSA being an institution that serves the city of San Antonio and in more general, the South Texas region. So proximity is also a factor. We want to provide opportunities, and we have done that for students that are extraordinary talented students. I could rattle a few names very quickly, but are tied to the geographic area of San Antonio. And so the UTSA gives them the opportunity to attend our programs that otherwise they could not.
By curiosity, what kind of software was used for the coastal engineering simulation?
Physics simulations are done in Abacus, is a finite element analysis program. It is one of many. Other people do these types of things with LS-DYNA. But it is one that we gravitate here at UTSA. We draw strength in numbers, and several departments use it. Their earthquake engineering simulations were done in an open platform. It's called OpenSeas. So it will change from problem to problem. But for those multi-physics, we use Abacus. I want to thank everybody for their interest in UTSA.